Okay, so first place, you saw this very well, that rho goes from 0 to r. Theta goes from 0, it's 0 there, and theta here to 2 pi. And then the one that's maybe a little tricky is pi that goes up to pi. And this again is because if here's your origin, x, y, and back here you've got a point, okay? Then it's clear what the theta is. You project up to here, and theta goes from here around to here. And theta could go anywhere. If you have a point over here, then you project up to here, your theta goes all the way around to here, right? But it's not going to go past 2 pi, because if it did, you'd be repeating points that are already here as pi starts at 0, right? Okay? Now what about phi? Well, if your point is over here and down here like this, well, phi is from the z-axis down to the radial line, or the line from the origin to the point, okay? It is radial with respect to the sphere, but you also have something that's radial with respect to circles, so I'll use a different word, okay? But the segment of length rho, okay? You got this, right? Now, if you allowed phi to go past pi, which would correspond to the point on the negative z-axis, then you would get a point over in the 7th octave, okay? I think that's the 7th octave. Yeah. 1, 2, 3, 4, 5, 6, 7, 8th octave. I can't count. Okay? I mean, I was going 0 to 7 for some reason. Okay. Right? Anyhow, if you allow this point to go past the negative z-axis over into this 8th octave, okay? Well, you would have to do that if you allowed pi or phi to go past pi. But you can already describe this with a phi that's less than pi, because it's the angle with the z-axis, right? And that would be, in this case, the closest angle to the z-axis. Well, the closest angle to the, as measured from the positive z-axis. Okay? Not sure that was a great statement, but ponder it. It makes sense if you think about it. So, for that reason, phi doesn't go beyond pi. Okay? So what integral does this give us? Now, you know, you got this. I didn't have to tell you anything. Okay? And that's a good start. Of course, it gets harder. Let's get this done. Okay? So, what's your integral? Gotta pull this back a little further because you know, the increment is a little big. Okay? Well, you're going to just integrate, again, 1. And your volume increment is rho sine phi d rho d theta d phi. Okay? So, what are your limits in rho? Well, it's 0 to big R. Your limits in theta are 0 to 2 pi. Your limits in phi are 0 to pi. This gives us what? Well, writing it out, because you did make a mistake here by not being quite detailed enough, something that you have good reason to be, since I'm a little bit flawed that way sometimes. Often. You're going to have rho squared over 2, right? Evaluated between big R and 0. Okay?
I have to like try to put effort into what I wear now because if I just wear like leggings and hoodies,
You agree?
Thank you, so do y'all. Y'all like
Okay. Well, there might be something wrong here, so let's, because,
Isn't that rho cubed over 3?
yeah, should that be rho squared?
That's what I wrote down.
Yeah, well, it probably should be, because if it isn't, it doesn't give you the right result, right? So let's go back and look here at what I did wrong, you know, right? Consistent with what I did. I have a row here and I have a row here, right?
That's where I got
So it's row square. Okay? So that was a little bit careless on my part. So that's row cubed over 3. Okay? That was going to work out. You know, you get your result is 4/3 pi r cubed. Okay? First place, you're not going to get an r squared. You're going to have a 3, and that's the only place one's going to come from. So at this point, we debug, go back and say, oh, geez, right. Okay? And then it's d theta d phi, right?
and your sine of phi.
Yeah. Told you. Watch me. Okay. So it's sine phi d theta d phi. Okay, well, evaluating this, you're going to get r cubed over 3 minus 0, which is just r cubed over 3. And that doesn't depend on theta or phi. So just write it outside the integral. And then that'll be the integral. Tempted to skip a step here, but I'm not going to. Okay, antiderivative of the sine is cosine, right? It's the negative of the cosine. Okay? I mean, what's the derivative of the cosine? It's the negative sine, right?
Yeah.
So it had better be negative, and then we'll see why when we write this step. Is that why you're hesitating, because it's negative?
No.
Okay, what did I mess up this time?
Phi only goes from 0 to pi.
No, we're integrating with respect to theta. Theta goes from 0 to 2 pi. Oh, wait, yeah. Yeah, we're integrating with respect to theta. I just integrated phi as if it was theta. So like I say, we want to write it out carefully step by step, okay? Unfortunately, I did a lot of this in a plane too. I'd integrate something, get something that didn't make any sense at all because I wrote down the wrong symbol. So this is theta, and we'll write in the sine phi d phi, right? And clearly then you got 2 pi minus 0, which is just 2 pi. And then it's the integral from 0 to pi of sine phi d phi. Now here's where you made your mistake after you saw me make all these mistakes. Okay? You didn't write this out carefully enough. Okay? So this is what? 2 pi r cubed over 3 multiplied by cosine phi, but it's negative cosine phi, and I was so anxious to get to that I got to it before I should. Okay? Evaluated between 0 and pi. Okay? Which is, if you write it carefully, is this, right? Cosine of pi is -1, as you know from the circular definition. Immediately visualize. And if you don't, be sure you learn to. Okay? And then it's minus -1 And minus negative 1 is 2, minus negative 1 is 1, minus negative 1 is 1, so you get 2, right? So that's how you get 4pi r cubed over 3, which is a formula that I have no objection to.
Really?
Because there's no cross-sectional area thing, it's not constant, right? It doesn't reduce to a prism or a cylinder in any way, right? So why it's this, in terms of basic geometry, it's much more complicated than this. Okay? It's very simple here. So that's why that formula. Now you can do it in terms of steradians and solid geometry and stuff, but nobody even does plane geometry at a
I wish I was working there before I started here, so I do.
pubescent teenager's level. Okay? Much less at an adult level. So there's no way you're likely to see that in terms of the geometric argument that the Greeks used, because they didn't have calculus. And it really irritated them. They went to war because they were just ticked off because they didn't have calculus. They said, we need calculus. We're going to go out and attack Athens or whatever, or Sparta. Okay, well, I don't know. I think I've got my history wrong. You understand what I'm talking about, okay? They're pretty proud of what they did. It was pretty incredible. So, you know, give them a pass just because they were irritated about not having calculus. We don't worry about that.
They were about 1,000